We are now at lesson 8C. In the next preview assignment and in the next class, you're going to need to be able to use a spreadsheet to generate graphs of linear, quadratic, and exponential models. These are three words you need to go ahead and get in your glossary or Google Docs or flashcards, whatever you're doing to keep up with vocabulary words: linear, quadratic, exponential. We're going to start with linear and quadratic. Question number 1. But wait, before you start listening to this video, make sure you go ahead and work on question 1, all of its parts, and then come back and let's work on this together. Question 1 says we're going to compare the graph of a linear model and the graph of a quadratic model. Linear model, quadratic model. The first model has the equation as you see here, and the second model has the equation you see here. It asks us in part A, which of the models is linear and which is quadratic. This first one is linear, and I also want to point out there's a little 1 hiding right there, 2x to the first power, and the second one is quadratic, and I want to point out there's a little 2 right there. Part B, what do the equations for these models have in common besides the use of variables x and y, or y and x? You could have written down several things. One of the things that I'd like to point out is that right here, it's 2 times x, and this one is a 2 times, it's x squared, but that would be 2 times x times x, so that's still something similar. And then both of those multiplications are followed by a subtracted 3. So that's something that they have in common. Part C, what makes them different? And differences, make some notes and a couple of thoughts you could put, is that one has the power of 1. This one, the quadratic, has a square, it's a power of 2, and the linear has a power of 1. It's to the first power. And what is the question? Part C, what makes the equations for these models different? Yeah, one is squaring the x before multiplying by 2, and the other, and then subtracting the 3. And the linear model does not. It just says 2 times x, and then you subtract the 3. Part D is asking us to set up a spreadsheet so that we can graph both of these models with values of x between -10 and 10. The directions are there. You need to try this by yourself before watching the rest of this video. So hit pause, work on part D, and then come back and we'll walk through it together. Step 1 asks us to label this cell as X, B1 as Y1, and C1 as Y2. It then asks us to go ahead and place a -10 in cell A2. And then it gives us a little formula to type in where it's equals A2 plus 1. That gets us from -10 up to -9. And then it says use the little drag down trick, and that'll get us -10 all the way down to 10. But then part E asks us to explain why the process in part D generates the answers generates the integers between -10 and 10. A possible answer you might write is that since we directly entered -10 for the first value, the next row, the spreadsheet added 1 to this -10, which resulted in -9. And when we copied and pasted and dragged it all the way down, it just kept adding 1 to each row until it told us, the author told us to go down to row 22. They knew that once we stopped there, that would get us all the way up to 10. We'll continue on with part F. Now it is asking us to graph the two models on the spreadsheet. It says in cell B2, right here, it is asking us to type equals 2 times A2, and then subtract 3. Okay, that gets us a number, and then we're going to use the drag down feature for that to replicate itself all the way down to 10. And then it asks us on step 2 in C2 to type in equals 2 times A2, send it up to, which is shift of 6, 2, and then we're going to minus 3. So we're getting some number here. And there we go. It's asking us on step 3 to use the spreadsheet to generate the line graphs. And so I'm going to hold this one down. Oops, I need to actually hold it down. What am I doing? We can do this. So holding this down with control, I'm going to go grab the other columns. I'm going to go up to Insert, Charts, and right here, I'm going to tell it OK. And looking at, and I didn't grab the top part, so it's just calling it Series 1 and Series 2, and it would have called it Y1 and Y2 had I grabbed the top part also. But looking at both of these, Part G says, how are the two graphs different? The first one, Y1, is our linear model, and it is a straight line. The second one is a quadratic model, and it's curved. The linear model increases everywhere, like from here all the way up, but the quadratic model is decreasing, and then there is a point where it starts increasing at x equals 0 to be exact. A quick reminder, this is a great time to hit pause and for you to complete question number 2, and then come back and we'll work it together. Question number 2 begins by saying that next we're going to compare the graph of a, where am I? Here I am, linear model and a graph of an exponential model. Think back to the very start of this worksheet, we said that we were going to look at comparing linear, quadratic, and exponential. The first part we compared linear and quadratic. Now we're looking at linear and exponential. The linear model is, as you see here, and I want to point out again that it's x to the 1, the first power, and the quadratic model has this going on. So it's got some times going on, it's got some exponent going on, but it isn't a 1 and it isn't a 2, it's an x. So as in question 1, the first question is linear, but now the second one is exponential. Why do you think that the second model is called exponential? You can provide several answers. One is that there is an x in the exponent, hence we call it exponential. Part B asks us to use the spreadsheet, generate graphs for both models on the same set of axes for the values of x between 0 and 15. To do this, we're going to follow our steps from question 1, B and F, modifying, using asterisk for multiplication, etc. So now looking at part B, it wants us to go ahead and use our spreadsheet to generate these graphs. I've already got my x column, 0 to 15. I've got Y1 and Y2 started, but I need to go back and look at these equations. And the first equation is asking us to put in for y equals, it's going to be equals 50 times, which is shift 8, whatever's in my x column, and then I want to add 1,000 to it. So that gets me a start, and I'm going to drag it on down so that it'll populate the rest of the cells. In Y2, this is my exponential column. It is asking me that y equals, asking me to put in that y equals 1,000 times shift 8, parentheses, 1.05, close parentheses, send it shift 6 up to the value in, somebody didn't start theirs with equals. Now let's start this with equals and see how this works out. Now it'll recognize my A2. So the numbers are the same in the very first cells, but then the exponential appears to be growing faster than our linear. So I'm going to grab the whole column this time. Actually, let me just go ahead and grab everybody. I'm going to go up to Insert, Charts, and I'm going to pick this chart where you see our Y1 is the blue line, which is still linear, but yet Y2 has a slight curve going up exponentially. So let's finish with parts C and D. Part C says, write one way that the two graphs are similar and one way that the two graphs are different. It is possible that you might want to say that both graphs are visibly increasing. You might want to say that the linear graph is a straight line, but the exponential graph curves a little bit. Part D, which graph grows the fastest, the linear model or the exponential model? And the answer is the exponential model. This concludes our lesson 8C. Look at our calendar and our syllabus. If you have more lessons to do, then keep watching videos. If not, upload these to D2L. Upload your worksheets to D2L, and I'll see you next week through video.